Hey everybody, I just want to spend a few minutes just to kind of give you some extra examples for determining the calculations regarding electromagnetic waves. So one thing that you need to remember is that all electromagnetic waves, whether they be radio, microwaves, infrared, visible spectrum, Roy G. Biv, ultraviolet, X-rays, and gamma waves, all of these electromagnetic waves travel at the same speed, which is the speed of light, which is 3 times 10 to the 8 meters per second. So in any of these calculations where it's either talking about a specific type of wave or it's inferring something about light being transmitted, light is part of the visible spectrum, okay? And all of those waves travel at 3 times 10 to the 8. So in most cases, your velocity is going to be 3 times 10 to the 8 meters per second. Now, unless you are referring or talking about sound travels significantly slower, which is the reason that we see fireworks explode sometimes before we can hear them, or you can see a plane fly by before you hear it, is because light travels so much faster. So the velocity of sound is 343 meters per second, and the velocity of light is 300 million meters per second, which is significantly greater. So this C right here can also be interchanged with V in any of these equations right here, okay, because it is a velocity. So number 20, it says radio waves travel at the speed of light. So right now it's telling you radio waves travel at the speed of light, which is 3 times 10 to the 8. So it's telling you the velocity is 3 times 10 to the 8 meters per second of those radio waves. How long would it take the Russians to send a message? So how long would it take? It's asking you for time. You have a spacecraft that's orbiting Mars, a distance of 7.8 times 10 to the 8 times 10 to the 10th meters. This is distance. Now this can also be expressed as 7.8 E10 meters. Alright, so looking at what I've got the velocity, the speed of light, which is how fast radio waves travel. I want to know how long it's going to take, so I need to solve for time, and I'm given distance. So I have velocity, time, and distance. The only equation up here that's got those three variables is V equals D over T. So there's our equation. V equals D divided by T. So now I plug in what I know. Velocity is the speed of a radio wave, which is the speed of light, which is 3 times 10 to the 8th. The distance of the spacecraft around Mars is 7.8 times 10 to the 10th. And the time is unknown. So time is in my denominator, so now all I have to do is I'm going to cross multiply. So 3.3 times 10 to the 8th times t is 3e8 t, and that leaves 7.8 e10 all by itself. So to get t by itself, you're going to divide both sides by 3e8. So you end up with t equals 7.8 e10 divided by 3e8, and that gives you 260 seconds. So what this is telling you is that it would take 260 seconds for a signal to be sent from Earth to Mars. Let's take another look at number 23 on this worksheet. Again, these are just examples that will help you with the wave math practice. It says microwave ovens emit waves of about 2,450 megahertz. It says, what is the wavelength of this light? And it tells you that mega is 10 to the 6th. Okay, so what this means is 2,450 megahertz is 2,450 million hertz, which can be expressed as 2.45 times 10 to the 9th hertz. Now, you should know by now, by previous Edpuzzles and notes, that hertz is a unit for frequency. So what this is telling you is the frequency of these waves. It says, what is the wavelength? So wavelength is lambda, which is unknown. And it's referring to light. In other words, it's an electromagnetic wave. It's talking about a microwave. And all of these waves travel at the speed of light. So the speed of these waves is 3 times 10 to the 8th meters per second. So I've got the velocity of this wave, I've got the frequency of this wave, and I want to figure out the wavelength. So the only equation that's got v, f, and wavelength is velocity equals wavelength times frequency. So velocity equals wavelength times frequency. So now I'm going to plug in what I know. The velocity is 3 times 10 to the 8th. The wavelength is unknown. Frequency is 2.45 times 10 to the 9th. Now to get wavelength by itself, I'm going to divide both sides by the frequency. So I get 3e8 divided by 2.45 times 10 to the 9th equals my wavelength. So when I type that into the calculator, my wavelength for this type of wave is approximately 1.22 times 10 to the negative 1, and wavelength is measured in meters. So 1.22 times 10 to the negative 1 meters. Let's look at one more example. And this is number 26 on this worksheet. It says the infrared astronomy satellite launched by NASA in 1983 had a detector that was super cool to enable it to measure infrared or heat radiation from different regions of space. What is the frequency of infrared light that has a wavelength of 1 times 10 to the negative 6? Alright, so there's a lot of information here. However, a lot of this is extra information. Okay, none of this information tells me anything that I really need to know, other than the fact that it's talking about infrared light. Okay, that part is important because it is an electromagnetic wave, and hopefully by now you know that all of these waves have a velocity of 3 times 10 to the 8th meters per second. So I want to know, what is the frequency of infrared light? So what is the frequency? So I'm solving for F. It even tells me here again, infrared light, that's electromagnetic wave, 3 times 10 to the 8th. And it tells me the wavelength is 1 times 10 to the negative 6. So wavelength is 1 e negative 6 meters. So frequency, velocity, wavelength, that's my V equals wavelength times frequency equation, where the velocity is 3 times 10 to the 8th. The wavelength is given to you now, and it's 1 times 10 to the negative 6. And I want to solve for frequency now. So if I want to get F by itself, and F is being multiplied by wavelength, I have to do the opposite, and that's to divide this over. So I end up with 3 times 10 to the 8th divided by 1 times 10 to the negative 6 equals frequency. So after typing this into the calculator, 3e8 divided by 1e negative 6, I get 3e14. And this is frequency, so it's measured in hertz, also referred to as cycles per second. So the number of waves that occur per second. All right, so use these 3 examples to assist you with the math practice as your assignment in a Google form. If you have any further questions, please feel free to reach out to me via email or join a tutoring session this Thursday.